Hello everyone, my name is Ashutosh Ranjan. I am a third year undergraduate from IIT Kanpur. I am doing a machine learning project under Skyfi Labs whose name is Credit Card Fraud Detection. This is the code for the project Credit Card Fraud Detection. I have imported several libraries such as NumPy, Pandas, Matplotlib, Seabond, which will be used for plotting highly attractive and informative statistical graphics. Then from sklearn.model selection, I have imported train traced split and cross validate for splitting the data and cross validation of data during the training respectively. Then I imported Gaussian NB from sklearn.naive Bayes. I have also imported confusion matrix classifications report from sklearn library. In order to select best features, I have imported select k based f classif and mutual underscore info underscore classif from sklearn.feature selection. I have downloaded the credit card transaction data from the website and read it into data using pandas.read underscore csv. We can see that the data contains various rows which are basically genuine and fraud transactions and columns which are different features and labels to these transactions. Using data.describe, we can find count, mean, standard deviation, minimum, maximum, and different percentiles of all the columns. Now, we can see that there are 31 columns, out of which the last column is class, which represents the label. If it is 0, it means genuine transaction, and if it is 1, it means it is a fraud transaction. Now we are finding the total number of genuine and fraud transactions and plotting them in a pie chart. So we can see that there are 2,84,315 genuine transactions and 492 fraud transactions in our dataset. Now I am separating the data into X and Y, where X denotes the feature columns and Y denotes labels. With the help of select K based feature of sklearn library, I am selecting best 10 features which would greatly influence the target value. Using kbase.fit, scores are calculated for each feature using f underscore classif score function. Now, using k underscore best dot get support, we will see which features are best or not. This will return a boolean array telling us which features are best or bad. Again, I am creating a list of features and storing them in all features and then classifying them into best and bad features. So here we can see which features are best and which features are bad. Now I am dropping the bad features from X because we don't need them. Now I am defining plot underscore fraud underscore genuine function which uses distplot feature of Seabond library which plots the genuine and fraud transactions of a particular feature. If the plots overlap each other, it means that it does not play the important role in deciding the label. But if there is very less overlap between the plots, it means that it plays an important role in deciding the label. Here we can see the plots of best features in which there is low overlap, also the plots of bad features in which there is more overlap. Now I am splitting the whole data into training and testing data. Now I am training the model using cross-validation technique because there are very less number of fraudulent transactions as compared to genuine transactions. So the cross-validation technique returns the training scores in the result and estimator of each iteration is also returned. This function internally makes the required number of splits, selects the chunks for training and testing respectively, trains the model, and returns the score of each split along with the model trained in that particular split. It returns a Python dictionary that contains the results. We will use the score to select the best model among the models returned by finding out the maximum score among the list of scores. Using this index, we will find the best estimator from the list of estimators returned by cross-validation procedure. Now, this function is basically used to plot the confusion matrix. Using this function, I am defining one another function, display results, which takes the estimator x and y as parameter. Now we can see how our model performs on the testing and training data. It predicts fraud transactions with an accuracy of 85% in the training data and with 88% in our testing data. So, thank you.